All right, we're back at it again. We're on day 4 for Unit 8. We're going to do a few of these practice problems for solving by substitution, then we'll get to the new stuff in a few minutes. Number 1, we look to see which of the two equations has a y equals or x equals, and I see the bottom has a y equals, so that's what I circle. And I'm going to plug it in for y up above since it says y equals. So now if we rewrite this, it'd be 3x minus, and instead of writing a y, we write my 2x plus 3 in parentheses. I distribute this negative 1 that's in front into the parentheses, so now I get 3x minus 2x minus 3 equals negative 2. So now I get x minus 3 equals negative 2. And to solve for x, I add 3 to both sides, and I get x equals 1. So that's half my battle. So now I go back to what I circled, this y equals 2x plus 3, and I plug in 1 for x to find out what my y is. So that'd be 2 plus 3, and in the end that gives me 5. So now my answer as an ordered pair would be 1 comma 5. And I always write it as an ordered pair, x comma y, because we're finding out where the two lines cross. Let's skip number 2 because we just did one like that. Let's go down to number 3 and 4. Okay. Yeah, both of those are good. And then we'll go on to the next page. So number 3, it says y equals up top, so that's where we circle it, and we plug it in for y down below. So now this will be 3x plus, and instead of writing y, we write negative 3 minus x equals 3. If I distribute the plus 1 in there, it doesn't change anything. Combine like terms, and I get 2x minus 3 equals 3. And then I add 3 to both sides, and I get 2x equals 6 now. So divide, and I get x equals 3. So that's half my battle. I found half of it. The other half would be plugging it into what I circled. So I'm going to plug in that x equals 3 into the circled equation and get negative 6. So now my answer is 3 comma negative 6 in the end. And I'm done. And then the last one we're going to do is number 4. Number 4 has x equals. So I'm going to circle what's after the x equals and plug it in for x now, since it said x equals that. So now we get 4 plus y minus 2y equals 10. There's nothing to distribute into that parentheses, so I'm just going to rewrite it without the parentheses. If I combine like terms, oh, that shouldn't be x, sorry. I wrote an x there, that should be y. If I combine like terms, I get negative y plus 4. And then I subtract 4 over, and I get negative y equals 6. I can't have a negative 1 in front, so I divide by negative 1. And in the end, I get y equals negative 6. So that's half my battle. And then on the bottom, I have x equals 4 plus negative 6. If I plug it into the top here, I plugged it into what I circled. And then that would be negative 2. So now we have negative 2 comma negative 6 is my answer. Any questions on that? Oh, any questions on that? All right. So let's go to the next page. This is the new part of the notes. Is just like with graphing, there's going to be some times where we have no solutions or many solutions. So those were the graphs that were parallel to each other or right on top of each other. So it says, remember from before, and that would be like a few, maybe like 4 or 5 units ago, when the variables all canceled out and you get a true statement such as 0 equals 0 or 5 equals 5, then the system has many solutions. So if the two things that are left make sense, then that's always many. if you get a false statement at the end where it doesn't make sense, so if the two numbers are not the same, like 0 equals 1 or -1 equals 1, then that's when the system has no solution. So you're going to get, with these special cases, some of the variables will all the variables will cancel, and then just look at the two numbers that are left and see if you're getting many solutions or none, all according to if you're getting two of the same numbers or different numbers. The same number at the end means that it's many solutions if all the variables cancel, and then if the two numbers are different, then that means no solution. So we would circle this -8x plus 15 and plug it in for y. So we get 8x plus, and then -8x plus 15, and then it says equals 15. So let's see what we get here. So that would be, if we if we distributed, there's nothing to change because there's no number in front of the parenthesis. So that would cancel out the x's, and in the end we get 15 equals 15. So we know that this is a special case because the variable's canceled. And if the variables cancel, we either need to decide if it's many or none. Since these two numbers are equal to one another, we would say that this is many solutions in the end. So that would be my answer for number 7. Number 8, we would circle what's after the x equals and plug it in for x down below. So now we would get 3y minus, and instead of x, we wrote 3y plus 12 equals 12. So we would distribute, and we get minus 3y minus 12. So the 3y's cancel each other out, and then in the end we get -12 equals 12. So that means that those two are different, and all the variables canceled. So that would be no solution. Questions on that? Okay. The next one here, we have y equals 2x minus 7. So we're going to plug that in for y down below. So we'd write 4x minus 2, and then parentheses 2x minus 7. That equals 3. We're going to distribute properly. We get -4x plus 14. I think the 4x's will cancel each other out. So now we have 14 equals 3. That does not make sense, so that's a no solution type. So if all the variables cancel and the two numbers don't equal, then that's no solution. Number 10, they're both x equals. So let's just circle 1, plug it in for the other x. So now we have 2y minus 8 equals 2y minus 8. We subtract the 2y from both sides, and we get -8 equals -8. This one, because they're identical, would be many solutions. All right, and the last two, this is y equals and y equals. So we circle the y equals on the top or the bottom, doesn't matter. Plug it in for the other y. So now we get 3x plus 5 equals 3x minus 2. Subtract 3x. And we get 5 equals -2. Those two are not the same, so this is no solution. And then x equals, we would circle after the x equals, plug it in for the top equation. So now we get 3 times 3y plus 5 minus 9y equals 15. So we get 9y plus 15 minus 9y equals 15. We get 15 equals 15 in the end. Those two make sense, so it's many solutions. So that covers substitution when you have the special cases of many or none. So that'd be parallel lines or lines that are right on top of each other. Okay, well, I'll see you tomorrow for the next day for day 5. Take care.